converging lenses and their diagrams. Remember, there are two main types of diagrams, lenses, converging and diverging. Now, remember the focus is on a lens is on either side because light can go through both ways. This is different from mirrors. For a converging lens, parallel rays come in and then they are refracted through to the focus. Now you can recognize a converging lens because it's fat in the middle and skinny on the edges. Now a converging lens can give you a real or a virtual image depending on where your object is. Now the thin lens equation is the exact same as the mirror equation. 1 over the focus is 1 over the object distance plus 1 over the image distance, where SO means object distance, SI means image distance, and F is your focal length. The magnification, again, is how large or small it is, and it is always the image height divided by the object height, and that's minus the image distance over the object distance, with the same meanings as mirrors. Now, sign conventions are pretty much the same for lenses. Okay, object distance is always positive. Now, the image distance, this is where the rays intersect, is real when the rays really intersect there. And for lenses, this is going to be on the side opposite the object. And it's going to be negative or virtual when they're on the same side as the object because the light rays are supposed to go through the lens. Think about your glasses. It'd be very hard to see anything if your glasses, if the images were always on the same side as the light. So the height is positive, means it's above the principal axis or it's upright, and a negative height means it's below the principal axis or inverted. You need to know these terms. Now, a positive focus means you have a converging lens, a negative focus means you have a diverging lens. And the magnifications mean the same thing. If the absolute value of magnification is greater than 1, then you have an enlarged image. Where if the absolute value of magnification is less than 1, you have a reduced image. And of course, as magnification equals 1, then it's the same size. Now, the ray diagrams are very similar to the mirrors. We're going to draw 3 rays, but you really only need 2. The first 2 are always going to work. The first one is in parallel, and then it's going to refract through the focal point. Now the second one is very easy. It goes from center all the way through. That's the easiest one to draw. The third one goes from the focal point or back toward the focal point, depending upon whether you have a positive focus or a negative, and then out parallel to the principal axis. Let's look at a couple of these. Suppose I have a converging lens. My object is way back here. Here's my lens. And remember, we're always going to measure everything from the center of the lens. The first ray is in parallel, and the light ray is supposed to continue on through the focus. So this one's in parallel, out through the focus. The second one is in through the near focus, and then it's going to refract out parallel. You see, we can already see where they're going to intersect. But let's do the third one, which is straight through the center. And you see I have this beautiful intersection of all 3 rays. So my image, you start on the principal axis. You put the tip of the arrow where the 3 rays intersect and draw your arrow. Now let's see. This one's real because the rays really did intersect there. It's inverted because it's upside down. And if we look at this, we'll see the magnification is less than 1 because this height, or my image height, is less than my object height. Now, what happens when you're inside your focus? You know something weird is going to happen. So let's do our diagrams. You're going to go in parallel, and it's going to refract off through the focus. The second ray is in through the focus, and then it's going to refract out parallel. Now you're already seeing a problem because those two bad boys are not going to intersect. Let's do the third one and see what we get. This one's going to go straight through the center. Again, these three rays don't meet. So you need to dot back the refracted rays. These are the ones with the arrows. Dot those three back, and you get that one. You get a nice little intersection where those three dotted back rays intersect is your image. Now, this is a virtual image because you had to dot things back. The rays are not really crossing there. They appear to come from here. It's upright because it's standing upright. It's in the same direction as my object. And this one's very obvious to see. This one's enlarged.